In this scenario, we've been tasked with connecting our data center to our existing network using OSPF. We have two existing layer 3 switches here. Switch 2 has a default route configured pointing to switch 1, and switch 1 has a static route to switch 2's network. Our DC1 switch has multiple networks that both switch 1 and switch 2 need access to. We can use OSPF on switch 1 and DC1 switch so that switch 1 can learn routes to the data center, and the DC1 switch can learn about the networks that switch 1 and switch 2 have. Now the DC1 switch actually already has OSPF enabled. Let's have a look in the dashboard. OSPF can be configured in a couple of places. The OSPF routing page has all of our settings, but you can also configure interface-specific OSPF settings on the routing and DHCP page by selecting an interface. We're going to look at the OSPF routing page here. And also notice that we're currently looking at our DC1 network. We can see that OSPF is enabled, and it appears that the timers are set at their defaults. We have our backbone area, area 0 defined, and the type is set to normal. And all of this switch's VLAN interfaces show up in the table here, and we can see under the OSPF column which ones have OSPF enabled. We have a few other OSPF related columns here too, like area, cost, and whether the interface is passive. Let's select one of these and have a look at where these settings are configured. I'll select VLAN 10. We can see that the interface is in area 0, the cost is set to the default of 1, and the interface is passive, which means that this switch is not running OSPF on the interface, but it is advertising this network to neighbors. If we go back, we can see all of this same information in the table for the other interfaces. Now we want our switch 1 to learn routes to all of these interfaces. They're all being advertised. So if we enable OSPF on switch 1 with area 0, we should learn about these networks no problem. And just to show you, if we go back to the routing and DHCP page and select a VLAN interface, you can see the same OSPF interface settings here. Let's configure OSPF on switch 1. I'll navigate to my San Francisco Building 1 network, which is where switch 1 is, and we'll go to the OSPF routing page. We're going to enable OSPF. We'll leave our timers at their defaults to match our neighbors, and then we need to add an area. We're going to keep this as a single area deployment, so that means it needs to be area 0, our backbone area, and this is a normal area. And then our interfaces, which ones do we want to enable OSPF on? Well, we want devices on switch 1's data VLAN to be able to reach the data center. So we'll select that one and choose Edit. And we'll set our area to 0, leave our cost at the default, and then passive. We don't have any neighboring routers on this subnet, so we don't need OSPF on it. We just want to advertise this network to our neighbor on a different subnet. So we'll set this one to passive, and that will eliminate the unnecessary traffic on our data VLAN. So we'll save that. And then what else? Well, in order to form an adjacency with our DC1 switch, we have to be running OSPF on their common subnet. We'll edit this interface as well, set it to area 0, default cost, and we don't want passive on this one. Save. And that should do it for switch 1. To verify our configuration, we need to go back to our switch page, and I'll select switch 1. And at the top of this page, we have an L3 routing tab. So here we have our ARP table, routing table, and our OSPF neighbors. And we can see already that we have one OSPF neighbor. It's our DC1 switch. And if we look at the routing table, we can see that we have learned routes for all 3 subnets at the data center. Let's try and ping one to test connectivity. We don't have to go far. In the Tools tab up here, we have a ping tool. And we can put in the destination that we want to ping. Let's choose one of the VLAN interfaces on DC1 switch. So 10.0.10.1. And we'll source the ping from our data VLAN interface. And click Run. And it's working. Awesome. We can reach the data center from switch 1 now. But what about switch 2? Well, switch 2 has a default route pointing to switch 1, And switch 1 has routes to the data center, but the data center switch doesn't have a route for switch 2's data subnet. Now we could run OSPF on switch 2, but we already have a route to switch 2 on switch 1, which has an OSPF adjacency with our data center switch. So we could advertise that static route into OSPF. We'll go back to the OSPF routing page for this. And then if you scroll to the bottom, we have a table of our static routes, just like we do for our VLAN interfaces. Here is our route to switch 2, so I'll select that. And our options are very straightforward. Do we want to advertise via OSPF? Yes. Do we want to prefer this static route over any routes learned via OSPF? Well, yes. In our network, this is the only way to get to switch 2, so we'll say yes. Select update, and we're done. So now, in theory, our data center switch should have a route learned via OSPF for switch 2. Let's check. We need to navigate to our data center network, and then we'll go to the switches page, and we'll select our switch, and then we'll select the L3 routing tab and check out the routing table. And there it is, our route to the switch 2 data VLAN. So now in theory, we should be able to ping switch 2's interface on that VLAN. We'll go to the tools tab and use our ping tool again. So let's source a ping from one of our subnets here and set our destination to the VLAN interface on switch 2's data VLAN, which is 192.168.40.1. And it's successful. We've got OSPF up and running in a matter of minutes.